Hello, and thanks for mathing with me today. In this video, we will write and graph equations in slope-intercept form. If a line has a slope m and y-intercept b, then we can write the equation of the line y equals mx plus b, which is called slope-intercept form. Remember that the y-intercept, as we learned in the previous video, is the point where the graph crosses the y-axis, so the point where x equals 0. We're going to start with graphing. So to graph equations that are in slope-intercept form, we're first going to identify the y-intercept and plot it on the graph. So in the example below, we have y equals 2x minus 1. If we're trying to find the y-intercept, it's going to be this minus 1 in our y equals mx plus b. So to graph the y-intercept, 0, b, the point will be 0, negative 1. The next step is to identify the slope. Remember, the slope is our m, so y equals mx plus b. In our example, the slope is 2. And if it helps, when you're determining rise over run, we can write 2 as 2 over 1. So what that means is when we go to plot our next point, we start at the point we have, and we go up 2 and over 1. And that's technically all it takes to graph an equation of a line. However, often it may be good to graph more points. So to graph more points, we just continue. From the current point that we had, the last point that we graphed, we go up 2 more and over 1. And then we go up 2 more and over 1. And we go up 2 more and over 1. And we can also go back 1 and down 2 and follow the same pattern. And this will give us points as much as fit on the graph. The last step is to connect these points with a straight line, hopefully going through all of your points, and to draw arrows on the end. Now it's your turn to try. Pause the video and graph the equations in numbers 2 and 3. Remember, identify the y-intercept, b, and then use the slope to graph more points. Hopefully you paused the video and you found that b equals 3, so the point is 0, 3, which is plotted right here. And then we use the slope negative 1. So remember, if there's no value there, it just means there's a 1 there. So negative 1 over 1 means I go from my point and I go down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. And that creates the graph of our line. In number 3, I have b equals 0. So if there's no b value, that just means b equals 0. So our point is the point 0, 0, which is the origin of the graph. Our slope is 1/2, so we go up 1 over 2, up 1 over 2. And then we can also go back 2, down 1, back 2, down 1 to follow the same pattern. Next, we want to use given information to write equations in slope-intercept form. Remember that slope-intercept form is y equals mx plus b, where m is the slope and b is the y-intercept. There are times where we're given the slope and the y-intercept, and we can just plug those values in for m and b and write our equation. There are other times where we are given maybe 2 points, or we're given a graph where we can identify 2 points. In these cases, we need to use these 3 steps. The first step is to use that given information to write the equation in point-slope form, which was the video previous to this. When we write the equation in point-slope form, then we can distribute the slope and then isolate y and combine like terms. So let's do some examples. In number 4, we have a slope of 2, m equals 2, and b equals negative 3. So our y-intercept is 0, negative 3. So remember, our form for the equation is y equals mx plus b. So all we need to do is plug in what we know. So we know that m equals 2 and b equals negative 3. So it's going to be a minus 3 instead of a plus 3. So y equals 2x minus 3 is our equation in slope-intercept form. Notice in number 5, we're given the slope, and we're given a point, but that point is not the y-intercept. In this situation, we need to plug our information into our point-slope form. If you remember from our previous video, the point-slope form is y minus y1 equals m times the quantity x minus x1, where our point then here is x1, y1. So we want to plug in our y1, so y plus 1, right? Y minus negative 1 is y plus 1 equals, our m is negative 2 over 5 times the quantity x minus 10, which is the x1. So what we want to do is we want to distribute this slope to both the terms in our parentheses. So that gives us y plus 1 equals negative 2 over 5x. Then we're multiplying negative 2/5 times negative 10, which is a plus. So we have 2/5 times 10. So when we simplify, 10 divided by 5 is 2, so we really have 2 times 2. And then we want to subtract 1 from both sides, so we isolate y. So that gives us y equals negative 2 over 5 times x. We have plus 4 minus 1, so it's a plus 3. So the equation of the line with the slope negative 2/5 and goes through the point 10, negative 1 in slope-intercept form is y equals negative 2 over 5x plus 3. Now it's your turn to try. Pause the video and try numbers 6 and 7. Remember that if you're not given the intercept, you need to find it. And if you're also not given the slope, you may need to find that as well. Hopefully you paused the video and in number 6 you found the slope to be 1/2. Remember that you could have used either point, so you could have used the point negative 4, 1 or the point negative 2, 2. In this situation, there are two different equations in point slope form. However, both equations in point slope form will give you the same slope intercept form. Therefore, your answer, regardless of which point you used, should be y equals 1/2 x plus 3. And in number 7, you could find the slope by counting how much rise over run. So that would have been 3 over 1. Additionally, the y-intercept is graphed, so that makes it easy for us to identify b as negative 1. When we plug both of those things in, we get y equals 3x minus 1 for our equation of the line in slope-intercept form. I hope in this video you learned to write equations of lines and graph equations of lines that are in slope-intercept form. Thanks so much for mathing with me today.